Today, we are unpacking what is honestly one of the most fascinating industrial transformations happening anywhere on the planet right now. We're looking at how India is rapidly shifting from making grand policy announcements to actual physical production in the fiercely competitive global chip race. So let's get right into it and see exactly how a massive domestic push is reshaping the global semiconductor map in 2026.
Here is our roadmap for today. We're going to cover the 2026 chip boom, Decoding ISM 2.0, the Pragmatic OSAT strategy, mega projects going live, top semiconductor stocks, and finally, the execution hurdle. Let's get to it.
Before we hit the hard numbers, let's just pause and think about this fundamental paradox. The semiconductor market is literally the most complex, capital-intensive, and cutthroat industry on Earth, right? So how exactly does a country just decide to enter it from a standing start? Do you go all in and try to make the most advanced chips immediately, or do you take a different route? Well, as you'll see, India is taking a highly pragmatic and honestly kind of surprising path to success here.
Section 1, the 2026 chip boom. Because to understand the how, we first got to understand the why, and that urgency starts right here at home. $155 billion. That is a massive number. It's the projected value of India's domestic chip consumption by the year 2031, which is more than double the current levels. I mean, think about it. From electric vehicles and defense systems to data centers and smartphones, the demand is just exploding. And this staggering $155 billion figure? That is exactly what's fueling India's core strategy. Demand-led import substitution. Basically, the immediate, urgent goal is to build chips at home just to feed this massive, insatiable domestic appetite. The main takeaway for you here? India isn't just trying to be a factory for the rest of the world, it's racing to supply itself.
Which brings us to Section 2, Decoding ISM 2.0. To turn all that ambition into actual reality, you need serious financial fuel, and that comes via the India Semiconductor Mission 2.0, officially launched in the 2026 Union Budget.
Now, what's really interesting about this is where the government is actually placing its bets. The total budget outlay for ISM 2.0 in 2026-27 is a solid 8,000 crore rupees, which was recalibrated to fight off some really intense global competition. But listen to the data here. While a massive 4,000 crore is targeted at bringing just one front-end semiconductor fab online, a much larger combined investment of 11,000 crore is projected across 9 ATMP and OSAT units. So the financial weighting heavily favors getting multiple downstream assembly and testing facilities up and running quickly.
Section 3, the Pragmatic OSAT strategy. This brings us right to the core philosophy of India's current playbook. Let's break down the strategic difference between the two extreme ends of semiconductor manufacturing. Think of it using an automotive analogy. It really helps clarify things. A front-end fab is basically like trying to build a highly complex, next-generation car engine entirely from scratch. You're talking astronomical upfront capital, extreme microscopic precision, and massive financial risk. On the flip side, ATMP, which stands for Outsourced Semiconductor Assembly and Test, is more like building the final car assembly line. You take the already built engines, which are the silicon wafers, and you assemble, package, and test them into the final consumer-ready product. OSAT requires way lower upfront capital. It gets you to operational revenue much faster, and critically, it allows you to rapidly upskill a local workforce. There's a fantastic quote from Avekas that says, "By establishing back-end operations, a country develops the industrial discipline, quality systems, and skilled labor that a future fab will need." And that perfectly captures the absolute genius of this strategy. Starting with the back-end OSAT operations, that is not about giving up on the dream of advanced front-end fabs. Not at all. It's a brilliant, lower-risk entry strategy that sequences ambitions rather than abandoning them. It lets India build that essential industrial discipline, figure out the strict cleanroom protocols, and train the skilled labor force right now. And all of that serves as the rock-solid foundation for those highly complex fabs later down the line. All right, Section 4, mega projects go live. And honestly, this is the most exciting part. This pragmatic playbook is no longer just a theory on a whiteboard somewhere. 10 fab and packaging projects worth 1.60 lakh crore rupees have actually been approved, and they are going live as we speak. Let's explore how this is building out geographically, because the scale here is just breathtaking. You've got Micron's $2.75 billion memory module facility in Gujarat. Right down the road in Dalera, Tata Electronics is partnering with the Netherlands ASML on a massive $11 billion front-end fab. Over in Assam, TSAT is building a facility meant to pump out 48 million chips a day. Then there's CG Semi's 7,600 crore partnership with Japan's Renesas and the HCL Foxconn facility in Juar. And get this, as of 2026, 3 of these approved projects are already in commercial production, including that CG Semi plant, which went from breaking ground to full production in just 27 months. That is lightning fast.
To really anchor these big numbers to physical reality, let's just consider Micron's operational site in Sanand. When fully ramped up, its first phase features more than 500,000 square feet of cleanroom space. To picture that, imagine roughly 10 American football fields of a pristine, ultra-sealed environment, completely dedicated to meeting the global demand for AI-fueled memory and storage. It is absolutely huge.
And this brilliantly illustrates the immediate real-world impact. To mark their grand opening, Micron didn't just stand around and cut a ribbon. They shipped their very first batch of made-in-India memory modules directly to Dell Technologies. These chips are actively being integrated right now into consumer laptops that are made in India for India. The supply chain is officially active, folks.
Section 5. Top semiconductor stocks. So, with factories humming and supply chains activating, let's pivot to the financial markets. And just a quick reminder, in this explainer, we are impartially reporting on the market layout based on our sources. We are absolutely not providing financial advice.
The policy is set. The factories are built. So who profits? It's the million-dollar question for anyone keeping an eye on the NSE and BSE. How exactly does this massive macroeconomic shift translate into micro-opportunities for long-term stock investors? Which companies are positioned at the key nodes of this brand-new value chain?
If we break down some of the top players by their specific role in the ecosystem, you've got HCL Technologies and Tata Elxsi really leading the charge on the chip design and embedded software side. On the physical manufacturing and packaging side, you're looking at Dixon Technologies and Kaynes Technology. And Kaynes actually just launched a massive OSAT facility capable of 6 million chips a day. And pushing into the heavy fabrication side, you have players like Fitanda. Now, for long-term investors, the calculation involves weighing a company's massive growth potential against their dependence on government policy and, of course, execution timelines. Your key takeaway? The ecosystem is wide, meaning opportunities exist across design, manufacturing, and raw fabrication, if you can stomach those execution risks.
Which brings us to our final part, Section 6, the execution hurdle. Because look, despite all this incredible momentum we just talked about, building a chip ecosystem from scratch is exceptionally difficult, and the road ahead is incredibly steep.
90%. This is a pretty sobering statistic. Despite the physical factories going up left and right, India still relies on imports for over 90% of its chip-making equipment. On top of that, between 85 and 90% of the highly specialized chemicals and electronic-grade gases required by the industry must still be brought in from overseas. So yes, the ecosystem is growing, but the upstream supply chain remains a critical vulnerability right now.
The hurdles are crystal clear. Beyond those imported materials, there is a severe shortage of manufacturing-specific talent. We're talking yield engineers, metrology specialists, cleanroom technicians. The industry has an urgent, pressing need to train roughly 85,000 industry-ready engineers by 2027. Plus, the current facilities are really focused on mature nodes. Building a robust ecosystem for advanced chips below 28 nanometers is still a long way off. So the crucial point is this: the talent gap is huge, but it is not insurmountable. Remember Micron's Sanand facility? They successfully trained and deployed around 2,000 workers within 3 years, using specialized training programs in places like Malaysia, so it definitely proves the workforce can be built.
And that leaves us with the ultimate question: will execution match the ambition? The strategy is brilliant in its pragmatism. The capital's deployed, the bricks are laid, and the first chips are shipping. But as the focus shifts entirely to day-to-day operational efficiency, aggressive talent acquisition, and supply chain localization, will the execution actually match that soaring national ambition? It's a fascinating industrial chapter unfolding right before our eyes, and it's one we will definitely be watching very closely. Thank you so much for joining me for this explainer. Keep learning, and I'll catch you in the next one.